think Kishore, you can move to the slides.
Yeah, okay. I'll do. Yeah,
Yeah, so
so
we'll start now.
okay.
So yeah. So hello everyone. Welcome to the summer school presented by Analytics and CBA Club of IITM. So we'll just run you through what summer school is and what we'll be covering throughout the summer school. And there are a few guidelines that we'd want to tell you. So we'll go through it one by one. Yeah, please go to the next slide. So, as you might know, today we'll be starting with basics of Python and like an introduction to Numpy and Pandas. Followed by the session on Friday will include visualization using matplotlib, uh, intro to machine learning, where we'll be implementing linear logistic and polynomial regression. And there will be a task, a data visualization task, which you can do over the weekend and submit by Sunday. Yeah, go to the next slide. So starting next week, we'll have understanding ML models where we'll be discussing simple vector machines, naive Bayes algorithms, and some performance metrics, and also tree-based models, ensemble methods, and recommendation systems. So, and then on the next Friday, we'll be starting with deep learning, where we'll be discussing the need for neural networks, and then we'll also be looking at perceptron learning algorithms like McLaurin-Blitz neurons and other neurons. And following that, we'll have a data science contest that will be posted on Kaggle, which again you will be able to do it over the weekend and submit. So yeah, moving on. Uh, and the last week we'll have three sessions which covers backpropagation, gradient descent, and other optimization algorithms, and also strategies for training neural networks, and also a simple introduction to OpenCV. So to get started with computer vision. The last session we'll be discussing some state-of-art computer vision models and brief intro on NLP and reinforcement learning. So to wrap up the session, we'll also have like deep learning hackathon, which we'll like let you know about the hackathon soon. Okay. So before we move on to the session, so there are like a few rules that we want to tell you. So to get the certificate of participation, so you'd have to like attend 80% of the sessions and also participate in all these three tasks and whatever in-session tasks that are there. So let's say that there is a quiz or something during the session, you will have to participate in those. So upon completion of the session, we'll be compiling your attendance, checking whether you have 80% and also satisfy the other criteria, following which the certificates will be mailed to you. All right. So also we like all the sessions to be interactive. So feel free to unmute and ask any doubts if you have, or put it in the chat box if you are unable to unmute yourselves. Okay. So make sure that you learn like the best out of all these sessions and also help us like make it more interactive. Yes. Over to
So
you,
the
Kishore. You
recordings
can.
and other resources would be shared before the next session, right? I mean, after every session, it would be shared.
Yeah, so we'll be putting it up on the GitHub repository, which I'll share after the session is over. And all the
Sure.
sessions content will be posted in the same repository.
All right. Thanks.
Okay. Yeah, over to you, Kishore.
Yeah, okay. So, uh, hello guys. I'm Kishore Kannan. I'm an electrical engineering sophomore at IIT Madras, and I'm also one of the coordinators in the analytics club. And I'm one of the instructors in this session, and I'll be teaching you Python. So, so let's start. So, what is Python? Python is a high-level programming language created by Guido von Rossum. And why do we use Python? So Python is very easy to learn. It has a much simpler syntax and it closely resembles English language. And unlike C++ and Java, where we use semicolons to end the statements, here we don't have anything like that. You will see it in a while. And then it also has a huge and rapidly growing supportive community. It also has a huge number of libraries and frameworks. And especially if you see machine learning, we have lots of good libraries such as PyTorch, TensorFlow, and you'll see them in further sessions. Yeah. So moving on. And hello world. So let's print hello world. So this is basically something that everyone does when they start learning a programming language. And so let's go to our notebook. So this is the print function, and the print function prints a specified message to the screen. So here this is the syntax print, and in brackets I have a string. So a string is always enclosed within the double quotes. So whatever that is there inside the brackets will be printed in the screen. So if I run this, yeah, just a second. Yeah, yeah, we got hello world. That's the output. And we can also do with the print statement. We can also do some more things. So here we have so I've initialized two variables. I'll talk about variables later. We have we print square of and then comma and then the value stored in the variable. So that'll be 3 and comma and then we print is, that is in quotations, and then comma and then we print 9. So basically what we are printing is square of 3 is 9. So that is what we are printing. So suppose okay, so let me run it. Yeah, so we get square of 3 is 9. And one more way to do it is to use something called f strings. So in f strings, so we the syntax is to just put a small f here before the double quotes, and then so wherever you want the value of the variable to be printed, you put that variable inside the flower braces. So like here, so B is in braces and A is also in braces. So if you print, you'll get the same output. And so these are the these green these lines of code that are in green. These are called comments, and they are not executed. They are ignored by the interpreter, and they're just used to improve the readability of the code. So I hope this is clear. This is the print statement. Okay, so moving on. Let's see. Let's look at the agenda today. So today we'll be discussing these topics. First is data types. We'll see how variables are classified using data types, and the next one is operators, how we can perform operations on variables, and conditional statements for decision making, and loops to iterate through certain variables or to repeat something over again, and functions for reusing blocks of code and to save time, and classes. We generally look at the basic level of object-oriented programming. These three list tuples and dictionaries form a part of data types, and then finally we
So,
look at yeah.
sorry to stop you. Maybe could you go back to that collab notebook and share the file with everyone so that they can follow along?
Yeah, okay, all right. One second. So
Go to share and then copy them. That'll be better. Make sure
Sorry,
it is.
maybe missed the first
Yeah.
10 minutes or not. So how to create this collab lab, and I'm new to this.
So we'll share the link with you. You can just use it directly. You can give view access to everyone.
Okay. So if you want to edit on our own, means do we need to create a one account, or else how it will be if you want to
So if
practice or test something?
you if no Kishore, don't give edit access. Just give view access, copy the link and paste.
yeah, we are.
So you can just use your own Google account to log into Collab. So it just requires a Google account, and you can edit it on your laptop basically.
Okay, okay.
So like you don't have to install anything. Just you can click on the link. It will open in a browser, and you can just use your Google account to log in basically.
Okay. Yeah, thank you.
Okay. And also Vasanta has asked to explain a little bit more about F strings. So basically F strings are nothing but editable strings. Basically you have like a string that is there, and then you can basically add some mathematical operations in between the string. So for example, you like prefix your double quotes or something with F. That means it is like editable, and you have all these mathematical operations enclosed in a curly bracket. So let's say you want to do P plus A, you can do that. So that is basically about F strings. It's basically a more functional string. That's it. Okay. Yeah. So everyone, please look at the collab notebook shared on the like chat. You can open it, and then if you want, you can follow along. So that'll be great. Yeah,
Sir,
sorry
I'm
to disturb you,
unable
sir.
to.
You can. Sorry, you are unable to.
Sir, I'm unable to access the chat box.
Oh, okay. Did you?
Yes, yes, we are unable to access it.
Shall I put it on the group?
Yes,
I
sir.
think if you had joined the session as a guest without registering before, then it might be the case.
Yes, sir. I wasn't able to join the team.
Okay. You can maybe wait. I'll send the collab notebook on the group.
Is the attendance considered only for those who join through app or the web app? I mean the browser desktop version.
How else can you join the session?
I mean from the website also, browser also we can join, right? Are you like?
Yeah,
Do
yeah.
do we have to download it on the laptop or
No,
the app
not
to
necessary.
get
Not
attendance or
necessary.
something?
Not
It's
necessary. I think all participants
okay.
like record will be recorded, so you don't have to worry about it. Okay, so I have shared it
Sure.
on the groups, and maybe after the session you could email, like send your email to me so that I can add you to that group so that you'll be able to access chat from the next time. All right. Okay, sorry, Kishore, you can move on.
Who asked for if it wasn't.
Sorry. Oh, it is
So
not
yes,
working, right?
it is not working.
Okay, so we'll figure it out. Maybe you can unmute and ask your doubts if at all you have any. We'll make sure that we send all the like important messages to the group so that you are able to follow along. Okay.
Do we have to fill the Google form compulsory to get attendance?
Which Google form, may you know?
It was mentioned in the group about some form.
So you had registered for summer school in a Google form, right? So that was the
Yeah.
form that they were talking about. No
All
need
right.
to like register again.
Okay. Okay. Yeah.
Okay, shall I
I
continue?
guess, yeah, you can.
Yeah, okay. So this is the agenda for today. And finally, we will look at the various Python libraries and Git and GitHub, the version control system. Okay, so moving on. First, let's look at what data types are. So basically, variables are classified using data types. So what are variables? Variables, you can imagine them to be something like a container, like a box. So let's name this X, and so this is a variable, and this is the data that goes inside the variable. So variables store data, and this is a label. This int label that's there on this box is a data type, and based on the data type, the variable will have different properties. And so, for example, this is a float data type variable, and only we can have decimal type now, decimal point numbers. We can store decimal point numbers in this variable, but we cannot store decimal point numbers here. Only integers can be stored in this variable. So that is about data types. And so if we look at the commonly used data types, we have integers, float, strings. Strings are nothing but characters, words, and sentences. Boolean values, and we also have sequential data types, which are list, tuple, range, sets, and finally we have some key mapping data types. Those are called dictionaries. So I will explain them in the code data types. So here I have declared three variables: x, name, and is it raining. So x is an integer data type variable, and it has the value 10. Name is a string data type variable, and is enclosed within double quotes. So all strings are enclosed within double quotes. And is it raining equals true, and you can see it's blue in colors, like unlike the other two. So this means this is a Boolean data type, which means it can either be true or false, and true is the keyword here. And so you can print the value stored in the variable using the same print function. So here, just give the print function, and inside it, you can just give the name of the variable, and it will print the value inside it. So if I run this, yeah, the output will be 10. 10, and for name there will be student, and is it training? Yeah, it's true. And we can also print the data type of the variable. So type of x will give the data type of the variable. So here x is an integer type variable. Name is a string data type, and is it training? That's a boolean data type. So yeah, so we get the corresponding output. And one thing to notice here is that, like, unlike the other languages, I haven't anywhere mentioned in the code the data type. So here I haven't said int x equals 10, or string name equals student, or bool is it training equals true. So Python is smart and intelligent, and it can automatically detect the data type. You don't have to mention it, unlike other languages. So the data types. And coming to operators. So operators, okay, now we have variables. What do we do with the variables? We can perform operations on them. So we have three class of operators. They are arithmetic. Arithmetic is just basic addition, subtraction, multiplication, division, and comparison operators for comparing the value stored in the variables, and logical operators uh, for uh, to check two or more conditions. So I'll explain them. So operators, uh, yeah, here we have addition, subtraction, multiplication, division, and modulus is nothing but the remainder that we get when, let's say, a percentage b. So a percentage b means it is the remainder that we get when a is divided by b. So yeah, so this is an example. Here I have declared two variables, a equals 5 and b equals 6. I'm printing the value of a plus b, b minus 2, a into 4, and this is b by 3, and this is a percentage b that I explained right now, a reminder, and this is the exponent, a to the power of 2. And can run this. Yeah, this will be the output. So that's arithmetic operators. Coming to comparison operators. So we have equality operator. So here we use double equal to sign. So equality operator checks whether two quantities are equal. And we use double equal to sign instead of single one because we use single one for declaring a variable or initializing a variable. So we cannot use a single variable for comparing. We should use only two equal to signs. And we have inequality sign, that's exclamatory followed by equal to, or we can also use this. And greater than, less than, greater than, equal to, or less than or equal to. And yeah, again, let's run it. Yeah, so there will be a equals b will be obviously false because 5 is not equal to 6. And yeah, similarly, so we have printed all the value of the expressions. And the last line, if you see a equals b, I've printed the type of this variable, and that is bool. So you can see that, like, a equals b is a boolean type expression, and that is why we get bool here, and also that's why the outputs are all true or false only. We don't get anything else. Yeah, so those are comparison operators, and finally coming to logical operators. Logical operators, we have three operators: and, or, and not. Again, I have declared two variables, a equals 5, b equals 6, and I'm printing this one, a less than b or a equal to b. Again, this is a boolean type expression, so the output will either be true or false. And so, or we use or whenever when at least one of the conditions should be satisfied. So here a equals b. So a equals b is obviously false. So that this is false, but a less than b is true. So one of the conditions is true. So the output will also be true. Next we have and operator. Here a less than b is true. And a plus b equals 11. That is also true. And finally we are printing not of a less than b. A less than b is true, and not of something will always negate the statement. So if a less than b is a statement, not of that will be the negation. So this is true, not of that will be false. So a less than b is true, so not of this will be false. So that's the output. So yeah, this is all about operators. So do you guys have any doubts? Like, Is there anything in the chat?
I guess no, Kishore, you can move on.
Yeah, okay, cool. So, coming to conditional statements. Conditional statements are used in decision making. And here we have three keywords. So, if, elif, and else. So, it's okay, I'll explain this with an example. So, here, yeah, so let's take this example. Uh, so, this is the general syntax that you see in green comments. So the syntax is if condition in brackets followed by colon, and then you in the next line the statement, and then like some statement will be executed if the condition is satisfied. And if that condition is not satisfied, then it goes to elif. Elif stands for else if. So and again this condition is checked. If this is true, then this is satisfied, and then this is executed. And again if this is false, then finally it goes to the else part, and where this will be executed. So in this example, we have is it raining equals true, and if is it raining, then it will print, oh no, I cannot play football now. Else it will print, let's go play football. So if I run this, yeah. So this condition is true. So the condition, this is the condition, is it raining, and that is given to be true. So the output, the statement executed will be this line. Suppose if I give this to be false, you can see this won't be executed because this condition is not satisfied. So it comes to the else part, and this statement will be executed. That is, let's go play football. And I have another example for elif. Uh, so let's say, yeah. So elif is this line is executed if the previous if or elif's conditions are not satisfied. So suppose say I'll give this to false. So initially summer is true. So if summer is true, then this line will be printed. So yeah, let's eat ice cream. And suppose if this is false and this is true, the next line will be printed. Let's play with snow. So because this is false and goes to next elif. If suppose both summer and winter are true, sorry, if both of them are true, then you can see we get only let's eat ice cream. We don't see let's play with snow because elif will be executed only if the previous if or elif statements conditions are not satisfied. So otherwise it won't be executed. So here this condition is satisfied. So this is true. So this line is executed. So the interpreter won't even go here. So we'll directly jump to the next block of code. So that's all about conditional statements. And so do you guys have any doubts? Okay, cool. I think we can move on. Okay, so let's go to loops. Looping means repeating something over and over until a particular condition is satisfied. Uh, and Python we have two types of loops. One is for loop and the other one is while loop. And for loop, like we use for loop when the number of iterations are known, the number of times you have to repeat the process. When that is known, then we can use for loop. Otherwise, it is intuitive to use while loop because like in while loop, we don't know the number of iterations, but we use certain criteria to terminate the loop. So let's look at loops. So just to show how powerful loops are, so here I have seven. Let's say I want to print "Welcome to Summer School" 7 times. So I'll run this. This is the traditional way of doing this. And with loops, this will take only 4 lines of code, and I can print the same thing. And suppose even if I can even print this 10 times or even 100 times, I just have to change this number right here. But here I have to, suppose if I want to print it 10 times, I have to add 3 more lines of code. So you can see how painful it is to do it in traditional way. So that's what loops are, and this is the while loop. And this is the syntax for while loop. This is the second loop that I talked about, second type of loop. So in while loop, the syntax is while in brackets we have some condition, and that will be followed by some statement. And this statement is executed repeatedly as long as this condition is satisfied. So, so suppose, yeah. So and then we also have an incrementing variable. So here that incrementing variable is t. So initially we have set t equal to 0, and that condition to be satisfied is t less than 10. And first it will print welcome to summer school, and then t will be incremented by 1. So again, let's check the condition. So 1 will be less than 10. So again condition is true, it will print welcome to summer school. Now t value becomes 2, 2 will be less than 10, again it will print, and it prints until like t becomes 10. So when t becomes 10, the condition is not satisfied, and so this one print. So that's all about while loops. And going to for loops. So for loops, just a second. Yeah, these are for loops. So this is a syntax, and this is how it looks. So for I in range, we give some numbers in these variables, and then some statement that is to be executed repeatedly. And this I is like we call this some counter. Let's call this a counter, and this counter will go from some initial value, that's the first number in the parenthesis, so you can see here, to some final value that is not included. So the range of I is, if it is from 0 to 5, which means I value will be 0, 1, 2, 3, 4. 5 will not be included, and it will be incremented by the value 1. So the values will be 0, 1, 2, 3, 4. So if I print this, 0, 1, 2, 3, 4, you can see. Suppose if I increment it by 2, the output will be 0, 2, 4. So skip counting by 2. And you can also print it in reverse. That will be 5, 0, and minus 1. So let's say that means it will start from 5. The ending value is 0, but it is excluded. So that will be 5, 4, 3, 2, 1. Why in reverse order? Because the incrementing value is minus 1. That's negative, so it will decrease. So it will be 5, 4, 3, 2, 1. So that's for loops. And coming to nested loops. Nested loops are nothing but loops within loops. So we have here declared a variable x equals 4. And here one loop. For simplicity, I'll call it I loop. And I'll call this j loop. So initially x is 4, and this is the initial value, and the final value will be x plus 1. So that will be 5 not included. So 4, and then the under that we have the another j loop. So initial value is 1, and the final value is I plus 1. And we have another print statement here. So if I run this, there we get 1, 1, 2, 1, 2, 3, 1, 2, 3, 4. So what's happening here is first I value will be 1, and the goes to the next statement, that's j loop, and then j value will also be 1, and it prints j, and then the final value is I plus 1, and I is initially 1, so I plus 1 will be 2, but 2 is not included, so it can print only 1, sorry, can print only 1, and it prints 1. Then it goes, and the I value is incremented by 1, so I value becomes 2 now, and again, so j can vary from 1 to I plus 1, which is 3. So it can, j value can be 1 or 2. It cannot be 3 because 3 is excluded. So it will print 1 and 2, and then next it will print 1, 2, 3, and 1, 2, 3, 4. So that's nested loops. So yeah, this is the overview of loops, and
Excuse me.
Yeah.
How it is going to new line? Can we print like welcome to summer school and sides welcome to summer school in a single line?
Welcome to summer school, and in
And
single line.
Single line.
Okay.
10 statements in a single line.
Yeah, you can do that. So there is something called separator. So that this is the command. So let's take this one. So if I print this, yeah, see. So this is a separator.
Thanks.
You use the separator to separate. If you don't give a separator, it will print in a new line. If you give the separator, The things that you're printing will be separated by this character, whatever character that you put here. Suppose you give a space here and print it. Yeah, so you'll get a space between each and every thing. You can also put any characters here. Suppose if I put something like you get a dollar here. Yeah, that's a separator. Okay, so any more doubts? Okay, let's move on. So coming to functions. So what are functions? Functions are modules of code that accomplish a specific task. And like functions are, you can imagine like a block of code that you can reuse it again and again. So that you can save like lot of time by just calling it, just defining it once, and then you can call it again and again. And function usually takes inputs, the data, and then it will process it, and then it will return some result. And yeah, like I said, it can be used over and over again. So yeah, so this is an example of a function. We define a function using the def keyword, and you can give any name. So I have given add nums, and inside it I have given two variables. These are called parameters, and this function will return the sum of the two numbers. So returns the keyword and return sum of two numbers. So how do you call the function once you define it? This is how you call it. You just give the name in the brackets, whatever inputs you want to give, you give it. So 2 comma 3. And suppose say if I print this, you can even print the output. So that add nums 2 comma 3. So these are the inputs that you give. So the 2 will go to here A and 3 will go to B, and then this will return A plus B. So this is equivalent to printing A plus B. So at this place, whatever that is followed by whatever that comes after this return keyword will come here, and that will be printed. So here we have A plus B. So here it will print A plus B. So that is function. So what is the use of this function? Like I can do this in a much simpler way, like just printing A plus B. So why do we need this? So you'll understand it why we need it. Like if you see this example. So suppose let's say we want to check whether a number is even or odd. We define a function like this. So def odd even, we pass a number. If num percentage 2, that is if it is divisible by 2, then it's even. Else return odd. Suppose I want to check for 4, 6, and 5. I'll just give three print statements and call the function thrice. So I'm calling it once here, second time here, third time here. I'll call it thrice. Yeah, and sorry. Uh, there is some error. Okay, sorry, I forgot to run this. Yeah. Okay, so you get even, even, and odd. But without functions, you will have to do it thrice. And suppose if I want for 5 numbers, I can just call it 5 times. But here, I have to repeat this block of code 5 times. So you can see how painful it will be. So that's the use. That's why we use functions basically. So functions are really powerful. So that's about functions. And like one more thing I want to mention here is that so this a and b are called parameters, and this 2 and 3 are called arguments. So arguments are something that you give as input to the function while calling the function. And a and b are the variables that you define while defining the function itself. So yeah, so like, many people confuse between these two terms, and the arguments are the inputs that you give to the function while calling it. Okay, so that's all about functions. And so is that clear? Like okay, so I think we can move on. Let's go to some basic object-oriented programming. In object-oriented programming, we use objects to contain data in the form of attributes and code in the form of procedures. So before thinking about this mumbo jumbo definition, I'll just tell you what objects are, and then you'll understand this better. So what are objects first of all? Objects can be anything. You can imagine a car or a pen to be an object, or like even the laptop that I'm using. Everything is an object. All real life objects. And objects can also be abstract. For example, like a system of government, you can say. So that's not real. Like you cannot. It's not. Yeah, so that's not real life object. So it can also be abstract. But what all of these have in common is that they have some attributes. Like this one, this pen has an attribute like this pen is black in color here, and this one is an ink pen, and writes in blue. Yeah, so these three things are the attributes, and it has some methods. Methods are nothing but the functions that the object can perform. So this pen can write, obviously. So that's one method. And let's take this Lambo. So this is orange in color. It's manufactured by Lamborghini, and let's say these tires are made of chromium alloy. So these are the attributes. And what are the functions that it can perform? The methods. That will be it can drive. You can drive the car. It can move. It can move in maybe faster speed or a slower speed, or you can put it in a parking mode. Like these are the functions that it can perform. So these are nothing but objects. Let's go to classes. So what are classes? Classes contain blueprints that are used to make objects. So for example, let's say we want to make a car object. So let's take this Lambo itself. So if you want to make this Lambo, so first we need to know the color, the engine that we use, the alloy that we are going to use, or the tires. Yeah, so many things. So basically, we need to know the attributes. So these colors, brand, and the, the materials that we use, they're all attributes. And we should also know what functions they should perform. If they should move, like how they should move, and what all they should be able to do. So yeah. So these information is contained by the classes. So we define the attributes and the functions that the object can, the methods the object can have in these classes. So yeah, so that's all about classes. And yeah, so let's go to code. So yeah, class is a blueprint of an object, and it is a way to bundle different data types together. And so yeah, so let's take this class pen. These are the attributes: type equals ballpoint, color equals blue, price equals 100. And like we can also have a method like the function can perform. So that's right. Let's call, we can define any method. So here I have given writing, and this is a keyword self. Self is a reference to the object. I'll explain it later in a bit. And then the thing it does is it prints write, and this is the class. And how do you make an object from a class? So to make an object, you just do like similar to declaring a variable. So you name some object, you give some name to the object, then followed by equal to, and then just give the name of the class followed by brackets. So this is how you create an object. And object is nothing but an instance of a class. And to access the methods of the object, so we can use the dot syntax. So C1 dot writing. So if you want to access the attributes or the methods, you can use a dot. So suppose, let's say I want to print the type of pen. So I'll give type. Sorry, this keyword. Yeah. So if I print this, write ballpoint. So if you want to access the attributes, just give dot and the name of the attribute without the brackets. If you want to access the methods, dot followed by method name and brackets. So that's an example. And yeah, self. Self is nothing but a reference to the uh, object, and it is similar to this pointer in C++ and this reference in Java. And like we, so whenever when you are declaring method, you should give this self. Uh, and yeah, that's a necessary keyword. And then like we also have this init constructor. So what is a constructor? Constructor is used to initialize the object state, like used to initialize the variables or the attributes, and then you can yeah, they used to initialize the attributes. So suppose, let's say, then what is the difference between this one and this one? If you ask, like I'll tell you. So here, let's take this class vehicle. So this is an attribute, vehicle type equals car, and we use this constructor self, then company one, color one, and So yeah, so these are the attributes: self dot company, self dot color. Like I said here, like you access the attribute using the dot function. So company and then equals company one, and this equals color one. And yeah, and then so this is the constructor. So what happens is, suppose let's say, so here we are making the object from the class. So we pass these two inputs, this Ferrari and red. This goes to this company one, and this is for color one. So company one, color one, and so self dot company is the attribute. So the value of the attribute will be set to company one, that is Ferrari, and the value of this attribute will be set to uh, color one, that's red. So when you create this object will have company's attribute as Ferrari and color attribute as red. So that is why we use definite. We use definite whenever you need to pass the attributes value for the attributes from the uh, like not internally but externally outside the class. So you're here you are doing it internally, but yeah. So here if you want to do it externally, you can do it. And this
Okay, Kishore, just a minute. Someone has a doubt, I guess. Yeah, yes, yes, Winnie, you can go ahead, ask it.
So, can you please explain the difference between instance, object, and class?
I'm sorry, I'm not able to hear you. Like, can you be a bit louder, please?
The difference between instance, object, and class.
Difference between what?
Object, instance, and class.
Okay, so object is nothing but an instance of a class. So class is okay. So object is nothing but, you can say, like any real life objects. So okay, let's say this. Okay, so I have this laptop with me, right? So that laptop that is there with me is an object. Okay, but the laptop itself belongs to a class of laptops. So how do you say? So class is nothing but blueprints. So you use the blueprints to make the object. So like you can say, if I'm not wrong, like objects are like very class is very common, and you can make objects out of class.
And so, what
Just, can you give like further clarification?
See, a class is something like a collection of objects. Okay, so let's say that human is a class, and one particular Indian is like an object. Okay, so objects are uh, like, how do I say? So you have int basically is a class, and you define a variable which is an integer. So the variable is an object. So like previously here defined x equal to 10, right? So the class is basically int, and x is an object. So object is basically something that represents an item which belongs to the class.
and so what is meant by instance?
Instance is basically one initialization. So let's say you want to, you can have multiple objects belonging to the same class. So each object is called an instance.
So, does that mean object and instance are the same thing?
Uh, an object is an instance, basically. These are all just like nuances. An object is an instance of a class.
Okay.
Okay. Yeah, so basically structures are collection of different data types. Okay, so structures are not necessarily present in Python, but you can substitute them using dictionaries. And structures basically in C++ are a collection of data types. So let's say you want to have one variable which has two, three attributes. Let's say one attribute is an integer, one is float, and so on. That is when you use structure. A class basically has attributes as well as methods. So for example, if you take this class that is pen, so these the attributes are type, color, and price, and your method is writing. Okay, so a struct only contains attributes, whereas class also has like methods to manipulate your attributes.
Okay, sir.
Okay, yeah. So I guess that's fine. Kishore, you can move on.
Yeah. Okay. So this is another example. Yeah. So I was saying this. So yeah, so we set the company one to be the attribute, company one value to the attribute company, and the color one value to the attribute color. And here we have one more method. So it's printing. Just I named it some random name. You can give any name here. So this will print vehicle type and self.vehicle. So yeah, like I said, you can access the attributes using the dot syntax, and yeah, the same goes with self.company and self.color. And yeah, so here I again create two objects, vehicle, and I pass two arguments, and there's a Ferrari and red, and the Ferrari is the goes with company, the company attribute, and red will go to uh, uh, color attribute, and the same goes with the other object C2, and company will be Mercedes and color will be gold. So we can, let's say if we print the details, C1 details, and yeah, here again I use a separator, and then you print it. So let's say I run this. You can see C1 details, vehicle type. Vehicle type will be car, because it's okay. So we are basically accessing this method using this dot syntax. So here in this method we have vehicle type followed by the vehicle type attribute. So this will print the vehicle type. So here vehicle type is car. Wait, next, in the method we have self.company and self.color. So both of them will be printed. And again, so we can access a class variable using class name. So yeah, the same thing. This is c1.color, accessing the color using the dot syntax. This is this attribute. So c1.color, see what is c1.color? C1.color, we gave it as red. So c1.color is color one, which is red. So that will be red. And then c2.company, that will be Mercedes. Yeah. So here, yeah, company, that will go, Mercedes will go to company one, and company attribute value will be Mercedes right now. So that will print C2. Yeah. So, and yeah, so that's all. That's object oriented programming basics. And now Akshay Vishwanathan from CWay will take up the other parts of Python and will also explain Git and GitHub. So over to you, Akshay.
Hello, I'm Akshay from CVI. Can you hear me actually, Archit?
Yeah, Akshay, you're audible.
Yeah, okay, fine. So we'll be looking at 4 data types, which actually store a collection of data. Like it's not feasible to store a lot of data. Each data will be having one variable. It won't be efficient also. So in Python, it has 4 data types. So we'll be having list and then tuple, then set. After that, we'll have dictionary. Dictionary is basically like structures in C, which some people might have learned already. So list, okay, list, it's like an ordered set of data, basically like an array from C. So each data will be having one index, and then the index will be starting from 0. And the elements in the list, which we call as literals. So we can change these literals once we define it initially. It doesn't have to be like once it's defined, it has to be constant, and it can't be like changed again. So yeah. So list will be starting from the index 0 and then going on till the end, and then length -1 will be the end of that list. And then if a person wants to access the list from backwards, from the end of the list to the
Akshay,
beginning. Yeah.
just a minute. Someone has a doubt. Roshan, go ahead. Please ask.
Yeah.
Okay, I think that was by mistake. Okay, sorry for interruption. Go on.
Okay, so in the negative index, like
Yeah.
0
3, 4, and like -1, -2, -2. Like, how does it relate?
So we'll talk about it. No, just give it like 5 minutes. If you still don't like if you still is not clarified, you can ask again. I think Akshay will cover it in just a moment.
Yeah. Okay, so the positive index which starts from 0 to the positive number till the n minus 1, and then the negative index which starts from -1. Both actually like overlap to the same element in the list. So in the example which I've shown here, so if you're accessing the index of 4 from this list, so it will give the value of e. And if even if you're accessing the element of index -1, it will also be giving the same value e. Basically, it's just for convenience. Either if you're going to access it from in the backwards direction, you can use the negative index. If you're going to access it in the forward direction, you can use it in the positive index. Is the doubt cleared actually? Okay, fine. So in a list, the letters don't have to be of the same data type. It can be a bool, it can be an integer, it can be a float. It can be of any data type, which was mentioned earlier as a numeric data type. So once you run the program for every list, we'll be storing it in a variable. The way you name the variable doesn't really matter. The syntax for initializing a list will be like give the variable name and then give an equal to initialize it. Then always use squared braces. So if you're gonna define a list, it should be a squared brace, or else it's not gonna consider it as a list. There are other ways also, like you can give it as a list of bracket, and then inside the bracket again you can define the list. So if you're going to access a specific element from a list, for that it will be okay. Same as how we do in arrays. Okay, if you have learned in C, usually for accessing element in array, we give the variable name which is given for the array, and then we mention the index in a square bracket. So basically, we do the same thing in Python also. We give the print function, and inside that we give the variable and then the index that we wanted that we are supposed to access. And then the length function, like it is used for strings, it can also be used for list here. Length of a list will give the length of that particular list, so that you will know how many literals are actually there in that. So a list doesn't actually have to be initiated in only one particular way with square braces. So sometimes you can just initialize an empty list, and then you can use a loop. So here we are using the loop for num in range 10. So num will be starting with the index value 0, and then it will be iterating till 9. So every time it iterates when num is in 0, so b dot append. So append function, right? So append function it will add one literal to the end of the existing list. So let's say you have an empty list. It will add one element to the list. If you have a list with only one element, so it will add an element to the end of the list with one element, and it will be a list with two elements. It will go on like this in the loop. So finally, when you print it, yeah, so we are printing it inside the loop. So each time in the append function.
Akshay, can you zoom in a bit?
Yeah.
Control plus.
Okay. Yes, it's fine. Okay. Okay, so the append function basically works like this. There are some other functions also which you can look it up if you're interested and then experiment with it. And then, suppose if we're going to initialize a list, we can't do it like the normal traditional way in which we are going to give a square braces and then give all the elements that we are going to store in it. Sometimes if the list is too large, it's not actually possible for us to do it. So in that case, we actually bring in a for loop, or sometimes it can also be a while loop. So we bring in a for loop, and then we use the append function to add every number one by one. Yeah, and then when you print it, it will finally be like everything will get appended and you'll get the final list. Yeah. So now with now that you know how to do how to initialize a list, let's say you we are supposed to access a particular set of elements in that list. So we call that slicing a list and then we'll print it. So we want in the list given in the list shown in the image. Let's say we are going to print elements starting from the index 1 till the index 4. So basically, just like you've learned in the for loops, here also we can give the indexes like the starting index and then the ending index plus 1. So the ending index you're going to specify it's not going to get printed. It always gets printed one index less than the ending index. Yeah. So in the list we have for B. In B we have numbers from 0 to 9. Each number will be equal to the index of positive index of the list. Yeah, they're printing the index from 1 to 7. So we are basically printing the indexes starting from 1, and then we'll be printing 2, 3, 4, 5, 6, and then 7 won't get printed. So it's the syntax is always like end index plus 1. And then okay, let's say you don't know the final index, ending index of that list, and basically you can get it from the length of the list function. So it doesn't have to be like that really. So for printing, let's say we start printing from the index 4, and then we're going to print the whole list till the end. So we just give the starting index 4 and then give a colon. Then we don't have to specify anything. If we're not specifying anything, the interpreter is going to take it as you're going to go till the end. So once it reaches the end, the loop, the interpreter is going to terminate, and then you're going to get the printed list. So in this case, it will be printing till 9. And yeah, accessing the negative index. So negative index, it starts from the end of the list. So we saw the list starting from 0 to 9. So when we're using the negative index always starts from the end of the list. So it will be like -1, and then the element which is one element before the last element, it will be -2. It will keep on decrementing -1, -1, -1 till it reaches the beginning of the list. So usually people use it to access a list in the backwards direction. It comes quite handy sometimes. So let's say we are doing slicing using the negative index. So if you're using the negative index, doesn't mean it's gonna like start from the end and then and then print everything till the starting. So even when you're printing it using the negative index, it's gonna start from the beginning of the list and then it's gonna print till the end. So the starting index we usually give it as in this case we have given it as -4. So it's gonna start from like -4, which should be -1 will -4 will be the fourth element from the ending of that list. So it will start from -4, which will be 6, and then it will print -3, and because it will keep on incrementing the index again and again till it reaches the end. So -4 and then -3, then -2, it will not get printed because it's always like end index -1 will be the index till which it will get printed. So this is basically everything about slicing a list. And then let's say we need a new we are making a new list, and in that new list we are gonna add the elements in the list B after adding it with 2. So if the first element of B is 0, the first element in list C should be 0 plus 2. So it should be 2 actually. So for this also we can use the same for loops, and then while using the append function, we can basically in the brackets we can add 2 plus B of I. I is basically the index of the letter there which we are accessing from the list B. So yeah, this is one way of doing it, but actually it takes more lines of code. So to simplify it further, Python allows something called list comprehension. In list comprehension, while initializing the list C, at that time itself we give the definition of how the list C should be inside the square brace. So here we have given the syntax will be, let's say we take the elements in list B to be as and variable x. So for whatever variable x you take from list B, the element in list B should always be x plus 2. So for that we give the syntax as x plus 2 for x in B.
Sorry, Akshay.
Yeah, tell me.
Sorry to disturb. I think could you share this link as well, the notebook link?
Yeah. I already shared it in the WhatsApp group.
Okay.
If you go and see that, yeah. Yeah. So list comprehension makes it easier to append one element from one list to another list. And in list comprehension, it doesn't always have to be a numeric operator. Sometimes you can also use logical operators, not logical. You can use comparison operators like we are making a new list D. So while initializing the new list D, we take an arbitrary variable x, and for every x in the list C, whichever element in list C is actually greater than 6, that will get appended into the list D. So you do not worry about in an index that element is not greater than 6. So what happens to that index in the list B when it is getting appended from C to B? So usually in append function it goes iteratively from first element to second element to third element. So basically the list D would get shortened, and then whatever element satisfies the condition x is greater than 6, that will get appended into the list D. And to change something that's already there in that list, it doesn't actually take much effort. So we'll be if we are changing the element in the index 2 in the list C, so we can easily change it by giving by just assigning a new variable new value to that index. So the old value will get discarded, and then the new value will be replaced there directly. And then okay, so we have a list of the variable C. C is a list that we are already having, and then we are going to remove a particular element from that list. Also, you should know that in a list you can store duplicates of the same value that you're using. 7 can be repeated 3 times or 4 times, how many ever times you want. So C dot remove of the element which you wanted to remove. So if you're going to give that function, the element 7 is wherever it's present in the list, it's going to get removed completely. And then the rest of the list will get printed out. The rest of the list will get, if you're going to use the print function, the rest of the list will get printed. So that will be all of list. Does anyone have any doubt in this? Okay, fine. So after list, we'll be looking at tuple. So tuple is practically a list in which after
wait, Akshay. There is
okay.
Actually, there is one doubt on the chat. So multiple occurrences of 7 will be removed, or will the first element?
No. Yeah. Okay. If you're going to use the remove function, whatever occurrences of 7 are there in the list, everything will get removed, not only the first occurrence. Okay. So yeah, tuple is basically a list in which in a list the literals are mutable. Mutable meaning after initializing a list, later on you can even change the value in that index, in a particular index. But in a tuple you can't do that. in a tuple, once you initialize a tuple and then give the variable, give the values in it, that's it. You can't change anything in that tuple. One set is always going to be the same. And then basically tuples are like, basically people use it as indexes, so that it won't get changed later on. Yeah. For defining a tuple, you can give any variable you want for a tuple. Any variable you want for a tuple. Yeah. Hello. Is anyone having a doubt? Okay. All the regular list operations apply to tuple, which do not attempt to change its own value. Yeah. Okay. So for defining a tuple, we give the variable name and then we give an equal to. Then we give rounded braces. So rounded braces practically mean that it's going to be treated by Python, the interpreter, as a tuple. If you give square braces, it's going to be treated as a list. For rounded braces, it's going to be treated as a tuple. And for printing tuple, it's going to be the same old thing. Give the print statement, and then inside the print statement, give the variable for the tuple. And yeah, if you're going to change the value in a tuple, it's not going to get changed. So it'll always going to give a type error if you're trying to change the value of some index in the tuple. Yeah. Yeah. But using a tuple, you can always build another list using a tuple. Like already I said, we can use the append function. From a list, you create another list. Same way, from a tuple also you can create another list, because it's not going to do any changes on the tuple. The tuple is going to remain the same, so it's not going to give any error. Here, we're going to make changes in the new list that we are actually defining. So in this example, for every x in tuple A, we are taking x and then multiplying it by 2 and then adding it to the new list that we are defining here, which is going to be E. Yeah. Finally, after that, if we slice it, in tuple you can also use the slicing function, because that's also not going to do any changes to the variable in that tuple. After tuple, we have okay, not dictionary. Okay, after tuples we have sets. So sets are always defined with curly braces. When you're defining a set with a variable, you always use curly braces. And in a set, if you even input a literal multiple times, let's say the variable, the string apple, it's being repeated by you like 3 or 4 times while defining the list set. So in a set, even if you define it for like multiple times, it's gonna get added only one time to the list. So later on, if you print the same list, it's gonna print the string apple only once. And in set, the way data is getting stored is always unordered. So we can't like have a particular index and then I'm gonna access this index and it's gonna give me a particular value. It's not like that. So in a set, it's always unordered. Okay. So methods of defining a set, either we can use curly braces or we can use the syntax set and then rounded braces. Inside that, you again give a list, which is gonna get which is gonna be treated as input for the set that we are defining. So on a set, we can do many operations. Let's say we have set 1 and set 2. In set 1, we have the list 4, 5, 6, 7, 1, 2, 3. In 2, we have 4, 5, 3, 2, 1, 2. Okay. So first, we're printing the set. So that will be directly done. Everything can be done directly by the print function, and you just have to give the variable that you're using to define each set. So from 1, like I said, we have given it in a different order, but it's getting printed in a way different order. It's getting printed as 1, 2, 3, and all. Yeah. Does anyone have any doubt? Okay, fine. Yeah, it's gonna get printed in different order that we can't really specify. And then in the when you see the list set 2, in the set 2, the literal 2 is actually repeating twice. But when you see it in the print function, the 2 is getting printed only once. So as I told you, even if you define an element twice or thrice in a set, in the end it's going to take it as only one occurrence in the set. And then we can use the logical operators in. Sorry, can you mute yourself? Okay.
Sorted when.
I'm sorry, I can't hear you properly.
So will the set be sorted when we print it?
That I'm not really sure, but you can't experiment with it, and then maybe you can find it later on. So as far as I know, I think
it is not sorted technically. You see that banana, apple, cherry is there, right? So that is not printed in a lexicographic order. So it is some random order. Okay.
Okay, sir.
Okay, so on a list you can also perform logical operators. So taking list 1 and then performing the AND operator with the list 2, so you get the so basically, like we have learned in math for sets, it's going to give us the intersection of both the sets. So whatever variable is getting repeated in both the sets, it's going to get printed as the intersection. And then there's union of two sets, for which you will be using the symbol we'll be using for OR operator. So 1 and then the straight line, then 2, which will be giving us the union of two sets. Whatever is there in set 1 and then whatever is there in set 2, one occurrence of each element will be printed. And then the difference, difference is like whatever is there, if we are giving 1 minus 2, whatever is there in set 1, and then if the same element is repeated in set 2, that element alone will get removed, and then the rest of the elements in set 1 will get printed. Same way if you are doing it like, okay. We are doing it as 2 minus 1. So whatever is there in set 2, after that, whatever is there in set 1 are both going to be compared. And if elements which are same in set 1 and set 2 are going to get removed from set 2, and the rest of the elements in set 2 are going to get printed. But actually, in this problem, all the elements that are there in set 2 are always there in set 1. So set 2 is going to be printed as an empty set when you're calculating the difference. Yeah. Okay. So dictionaries are basically like structures which you would have learned in C. So we give an index. An index is basically like a tuple. So whatever index you give later on, you cannot change it. And then each index will have some key values. Those key values are treated like a list. So for each index, each key will be each key is immutable, and each value for the corresponding key is always mutable. Yeah. So let's take an example like we are storing a friend's phone number. Okay. So we are defining the dictionary phone number, and then for dictionaries we usually define it using curly braces. So the first will be define first we'll define the key, and then followed by a colon. We'll be giving the value for each key. So each value will be mapped to the corresponding key to which you have given the colon. And it doesn't have to be always like in a dictionary you can always add more indexes, and then with more index you can always add more values to each index. And once an index is added, it doesn't mean you can change the index afterwards. So indexes are immutable, basically. So in the dictionary phone number, instead of giving the input in a curly braces, we can also give it in this form. Yeah, phone number and then square braces, and then the key value which they're going to give, followed by an equal to operator with the key. So to print a particular key to print a particular value of a key in a list. So for that also you can use the same syntax. It's print and then the list variable name followed by a square braces with the key value. So whatever values are stored in that index, it's going to get printed. So sometimes after giving a value for an index, let's say here Harish is changing his number afterwards. So to change the value in that particular key value, we can directly use the same syntax like phone number, square braces, the key which we are going to change the value for, and then followed by the equal to and key. It's really simple actually. So yeah, in a list, if you're giving a key doesn't actually mean that it always has to be mapped to one particular literal. It can always be mapped to another dictionary as well. Like the key Harish here is getting mapped to another dictionary altogether. So you can store another dictionary inside one dictionary under one key. So under the key Harish, you again have his number and his email. Both will be considered as one dictionary sub-dictionary, which will be added into our main dictionary with his phone number. So to access it, we can just print off phone number. It's going to give us all the details in the particular list. Yeah. So after, does anyone have any doubt? Okay, fine. So we'll take a short break after this session. After that, which will be after which we'll be learning about quite more introduction about Python libraries, and then how to import libraries and use it on your own system.
Yeah, go ahead, Jaydeep.
Is there any doubt?
Yes. Can you show how to print the like only the email from that Harish's dictionary?
Okay, print only the email. Archis,
See, basically, what you can do is phone num Harish of email. So, like how you print phone num of Harish, same way you print phone num Harish of email. You can type it, no?
okay.
Like add a new cell and type it. So you can add phone num of Harish of email. Use the square brackets, man.
Phone name of Harish of again as a
Outside that square bracket.
Yeah. So So basically, this will be printing the email of Harish.
Yeah, thanks.
So then we'll be starting with Git. So Git is actually like Git is basically a version control system. So let's say a company is starting to work. Okay, that is. So let's say you're starting to work on a project. In a project, you will be having many steps. First, you'll be adding some changes, and then sometimes the changes may not be correct, so you want to go back to what you had initially. So basically in Git, it will create a hidden folder, uh, which will be working alongside whatever changes you're making in your uh, particular file. So initially, master. So Git, when you're creating a Git, initially a repository will be created. So once a repository is created, that in that repository, there'll be a header which will be pointing to the initial position, the origin file which you'll be already having. So that will be stored with a variable, in the Git file, which will be hidden from you. So in the beginning, you'll be starting with the master branch. So let's say you are going to make some changes to the files in that particular repository. So once you've made some changes, uh, after you made the changes, we can actually add it. Yeah. Once you made some changes, those changes you can add it to the staging. The place where you're making changes, which you actually called the working tree. So once the changes are made in the working tree, they get pushed into the staging area. And then after getting it into the staging area, we use the git command, git commit command to store it into the git repo. So git repo will store all the details about your file, whatever changes you made, and then it will also show who contributed to it, and it will have its own separate identifier. So it will be like a six number variable. Yeah, that I'll show after some time. Yeah. So basically, Git will be on your local system. If you sometimes people across various places might be working on the same project at that time, GitHub comes into the picture. So GitHub uses Git as its root, and each repository commit, it's going to get saved into the cloud. It's going to get saved into the cloud system, which is handled by GitHub. Yeah. So it can be made public or private. I'll just show you the website. Okay. So this will be the GitHub website where you can create an account of your own, and then you can create new repositories in which you'll be storing all the files you're making changes, and each change will be stored in a separate commit, which you can access later on if if it seems like you wanted to revert to the previous change of your file you already wanted to have. So yeah, actually, this is the webpage for GitHub. You can also go to like yeah. So the GitHub desktop, you can download it from here, and then you can use it on your desktop, which will be working simultaneously with your GitHub, which is there on the cloud, and then the local repository, which you will be creating on your own system. So for first creating a repository, we'll be like we'll giving it some name. Let's say this is for testing one. And for each repository, you can give your own description for identifying it later. And then you can add a README file to a Git repository, which will be giving the data of whatever you're storing in that Git in that repository. git ignore is like basically sometimes when you make changes, your system files will also be having some changes in the same repository, which will get ignored by the git. When you use the git ignore command, it will ignore all the system changes that you don't need to be saved, and a license that actually isn't needed actually right now for us. So yeah, after creating a git repository. One second. Okay. So this will be a new Git repository which will be stored in your account after you create an account using your email. So in this, you can do make changes and then upload your files and then access them later on directly, which will be available here. So this is my initial commit. In my initial commit considers has the README file. So initially, there's nothing in the README file. So I'm gonna clone this Git repository to my own local system. So for that, you have to go to the code here and then copy the link over here. So once that is copied, you can go to the command prompt and then give the command to git clone. After giving the git clone, you just have to give the link that you've copied from your web page GitHub. Once you press enter, it will be like cloning into testing one. And then finally, when it gets cloned, it will be cloned. A new file will be created on your folder. File Explorer, if you go to your File Explorer and see. Okay, user. Yeah, here we have the testing one file, which has been created after cloning it from my GitHub repository. So this will just have my readme file. So let's say so I have my collab notebook here. So so if I directly copy this collab notebook and then I'm gonna put it in my newly created repository, local repository. So once I put it in here, yeah, this would have made some. I have made some changes to my Git repo. I have made some changes to my Git repo, which is there in the working tree. So that this local area which I have, this is my working tree. So once I make some changes to the working tree, let's see if it is to check the status of my Git. I'll be like Git status. Okay, first I have to open my file. Testing one. So CD testing one will open into my testing file, and there I will see the status. Okay, your branch is up to date. Okay. So changes for changes to be committed, first okay. So while using GitHub, we first create a new repository, and then we clone the repository into our own local system. After that, we add files and then commit changes to it directly to the cloud system. So this can be done through a series of commands. Cloning can be done through it can be done through the GitHub desktop, which if you download the GitHub desktop, yeah. So once you've downloaded your GitHub desktop, okay. First, since we have made the changes in the GitHub cloud system, we need to fetch those details over here. So I already have a repository Python session over here. Let's work on this repository. So from here also, you can create a new repository or else clone a new repository into this. New testing one. So we'll be cloning it into our GitHub desktop. Yeah. So once the cloning is done, you can directly use it through your GitHub desktop. So for using the GitHub desktop directly, you can configure it directly through here. So here you give your name and then email for whatever. For integration, usually text editors can be used. So the text editor I'm using, external editor that I'm using over here will be VS Code, and then the shell where I put in all my commands for cloning the GitHub repository, for committing the changes. We can do it in different places in Windows. It can either be the command prompt or the PowerShell, or you can also install something called Git Bash. So once you install the Git Bash, it will also be like a command prompt from where you can do all your Git commands in your local system. So Sigma, Windows Terminal, anything can be used. And then in Git, you usually log in your account in the Git desktop, which will directly fetch details from your account which is there in the cloud. Yeah. So local, then clone to local system for changes to be made. Yeah. So the git add command will take the changes that you made in your working tree, which will be a local system, and the changes from the working tree will be added to the staging area. After it gets added to the staging area, you can directly commit it to your Git repo. Once you commit it to your Git repo, it will be committed. It will be stored as a commit, which you can access later on if you want. If you're thinking of seeing whatever you did in the past. Yeah. So here we are going to give the command git add dot this git add space and then a dot. This will add all the files you have in your working tree to your staging area. So once it gets added to the staging area, then you can use the git commit command and -m, which will be your message. For each commit, you can give your own message for identifying it later easily. So for this, I'm giving it as my first commit. Yeah. So once I did this change, it's going to get committed to my local repository. So after I make the changes to my local repository, it doesn't necessarily mean the changes are going to get reflected in the web page. So even if I reload it, yeah, the changes are not actually reflected in my GitHub web page. So to do that, I'll be using the command git push or yeah. So this will push my whatever changes I've made in my local repository. It will be directly pushed into the Git repository which is there in the web page. So from now I can access it through my cloud. Yeah, see. So now I have my Python Collab notebook, which can be accessed directly from the GitHub website. It will be holding all my data which I've pushed into the website. So this will be my repository which is there in the cloud, and then my local repository and cloud repository both have been synced now. So yeah, this is how you use your Git. And then doesn't necessarily mean all the time you have to use it through your command prompt. Sometimes the changes can also be made through the summary over here. So let's say you're making a change. I'll fetch all the details from the web page. Yeah. So since I've added one more file to the GitHub cloud system, so it's showing me that there's one change in the cloud system, and that's not actually reflected over here in my desktop. So for that, I'll be like I'll pull the origin and then it will get added to my local repository also. Yeah, so here I'll be having my first commit. This will be my initial commit. So amend commit will be like begin amend. Yeah, amend will be like if you want to do any changes to the message that you've given for that particular commit. So you can click on amend commit, and then it will take you to you can directly for summary you can give a different name for it. So I'll
Actually,
give us yeah. Yeah.
I think we are like overshooting the time. Maybe you can wrap it
Oh,
up in
okay,
a couple
fine.
of minutes.
Okay, fine. Yeah, so this is basically how you push your commit to the GitHub web page, and then how you pull it back to your system if it's there in the web page, and then finally, yeah, okay. So this is CVI Club GitHub web page. From here, if you want to take if you wanted to take any project from whatever they are doing, and then make some changes to it on your own. Maybe the owner of that repository might not allow you to do any change. At that time, you can just fork the project, and then once yeah. So you can when you're forking a project, when you're forking a repository, the repository which the owner has will get directly duplicated, and then the same repository will be cloned into your own account. So once I create a fork, it might take some time. So after that, yeah, see now it will be in my account, and I'll be having the same repository. So this repository has been cloned into my system, and I can use this repository to make my own changes. And then if I think my own changes are like really useful, I can create a pull request to the owner. So if they think my my commits are really good and it will be useful for them, they'll approve my pull request, and it will be taken back to the owner from where I have cloned my repository as my own. So usually, if a person has a public repository, you can clone it, you can post it, and then use it in your own account. But if the repository is not a public one, then you have to ask for permission, and there are many issues with license and all those. Yeah. So that wraps up my Git session. If does anyone have any doubts? Actually, you don't have to change anything during the particular install. I'd recommend you install git bash to directly run the commands for your local repository. Okay, then. Thank you. That's it
All right.
for this day.
We'll take a short break. Okay, so we'll take a break till 3:47, and then we'll start with Python libraries. We are kind of running short on time, so please excuse. So please be back by 3:47. We'll start with Numpy and Pandas today. Aniyu, if you want, you can set it up. Aniyu, the Srinivasan, whoever is going to
Okay, yeah.
start. Yeah.
Yeah, I'm audible.
Yeah.
Okay.
Yeah, you can start.
Okay. Okay, good afternoon, everybody. My name is Srinivasan, and I'm a coordinator at the Analytics Club, and I'll be introducing you to Numpy. So let's begin. This is basically what we'll be covering today. First, we have a background look at Numpy, and then we look into indexing and slicing, arithmetic operations, manipulating shape and stacking arrays. Then we'll be looking at some initialization functions, and finally we'll be touching upon file operations. So what is Numpy? Numpy is an open source library concerned with array manipulation. It has various functions for mathematical operations such as arithmetic, trigonometric, Fourier analysis, matrices, and so on. Right. So there is a lot of mathematical capability involved with Numpy. So NumPy, Pandas, and Matplotlib together offer the capabilities of MATLAB in Python. So why is it so useful? So you've seen lists in Python today, but a NumPy array is actually superior to a list for mathematical operations. And the reasons are that in a list, to store each and every single value, you need multiple other variables that are used internally to store the value. Whereas for NumPy, it is just the value, right? Also, in NumPy uses continuous memory like this. So when you store a NumPy array, you have, like, let's say this is the value 1, 2, 3, 4. So it'll all be stored sequentially in memory. Whereas for lists, normally with linked lists, it will be in different locations in memory, which will then have pointers pointing to those various locations. So having continuous memory is what makes indexing and operations faster on NumPy arrays. Also, you don't have to check the type of the object every time you read. So let's get started with some basic NumPy functions. So the most basic is indexing and slicing. So before that, I'll introduce you to. So this is the notebook, and we get started actually with what data sets are. So a data set contains rows and columns tabulating data from experimental or observational facts. Okay, so this tabular data is regular and it can be processed for purposes like machine learning, right? So this is what a data set looks like, right? So this is the data set we're going to be using today. It's much bigger than shown in the screenshot here. So I've already dropped both the notebook and the CSV file containing the data set on the WhatsApp groups. So please feel free to open them up and follow along. To run any of the commands that I've used, you will need to actually upload the CSV onto Colab. So I'll just show you how to do that quickly. So you go to this folder icon here on the left, and you click this upload to session storage, right? So this you have to do, of course, after downloading that CSV file that is on the group. So once you click this, you get an option to you get an option to choose a file. So you just click on serial and then you press open, right? So that'll get uploaded here and you'll be able to access the CSV values on Colab. So I've already done that, so I'm skipping it right now. This is how it should look once you've uploaded it. So let's get started. So first we use the CSV module in Python to extract the data. So the reason I'm extracting the data from the CSV using this module is that normally we would use Pandas to do this, but considering that we are using NumPy, let's not get into that. Okay. So this part of the code, essentially what it does is extract the data from that. So the headings contains, well, the headings in the CSV file. So that's basically this part. Right. So it will contain these headings, and the rows array the rows list rather will contain all these values. Okay. So let's run that and check it out. Right. So you can see that first we're printing the headings. So these are all the headings, and after that you have a two-dimensional array that contains multiple all the rows as lists. Okay. Right. So now let's turn towards indexing and slicing. So what's array indexing? Array indexing is the same as accessing an array element. So when you index an array, you're trying to access an element, right? Whereas slicing is not just one element, you're accessing multiple elements. Start from a start point to an end point, you're getting all the values into an array. So let's check that out. Right. So the starting is import numpy as np. Right. So we're creating this rows underscore array. That's basically what is just storing all these values as a numpy array. So here we have the rows list. I'm converting that into an array, and that's what I'm calling rows underscore array. Right. So this is the basic step. Basically, it's just printing. So the array, and you're just printing what the array is. The dimension of the array prints how many rows are present. So we can see that there are two. Right. So why is the dimension 2? Basically, you have this. You see, there are two square brackets starting at the starting. So what does that mean? It's an array of arrays. So it's a two-dimensional array. If you had three of these, you would have a three-dimensional array, right? And when you talk about the shape, you're talking about rows, comma columns. So in this CSV file, there are actually 77 rows. The reason it's 77 is because we're not including the headings, of course. And there are 16 columns. So it's 77 by 16 array. Okay. So now we'll get into slicing. So I'm going to slice the calories part from the CSV. So what exactly is calories? You can open up the CSV. You see this column. I'm going to extract this column and this column. The reason I'm doing that is because Numpy is a mathematical library. So I want to deal with columns that actually have numbers. So this is the slicing. So when you slice, it goes from the index in an array always starts from 0. So if I want the fourth column, like it was the fourth column here, right? So 1, 2, 3, and 4. So I need 3, right? So when I slice, if I put this colon, the colon basically means I just pick up all the rows, but the third index column, that's basically the fourth column. So it's going to pick all these values in one array. Similarly, the protein is going to pick all of these in one, except the heading. Okay. So, and then we're doing AS type. The reason we're doing this is because if you remembered in the list, we had encountered all. Sorry, does someone have a doubt? Okay. So the reason we're doing this is because you can see here the all string values, but we need numbers. So we're using the AS type function that will convert them into whatever type we mention inside. Here it's just int64. Basically, it's just a 64-bit integer, right? Normal int data type. So let me run that. And yeah, so all the string values have been converted to numbers. And if you have the CSV open, you can see that this is exactly the columns, the column for calories, and this is the column for proteins. Okay. Right. So now I'm going to try and print the data. So let's just explore what information is stored in this. So we can see that the data type of this is int64. It should be because I had typecasted it to 64. Right? The size of each item, because it's in, so you see it's in 64, right? So it should be 8 bits per item. And the array size is 77 because you have 77, you had 77 rows and you're talking about one column. So essentially you have 77 different numbers in this array. Okay. And if I want a particular element, so this is where indexing comes in. So I'm going to print from the rows comma array, I'm going to print 1 comma 0. So what does 1 comma 0 actually give me? Okay. So again, it starts from 0. So the row we're talking about is the second row. So that's 0 and 1. And the column is 0. So that's the first column, second row. So it should print this element, and it is 100% natural blank. Okay. Hope that's clear. Any doubts so far? Any doubts?
Yeah, actually, just a minute. Yeah, go ahead, Jaydeep.
What I wanted to ask is the numbering for the rows and arrays. So the Python NumPy wouldn't consider the title of the columns, right?
Yeah, the reason it's not considering is because if you see the notebook, right? So if you see the code I've written, when I extracted the data itself, I had separated the headings out from the rest of the data, right? If you hadn't done this, if you had just done for rows in this and rows dot append, then it would have considered everything. But the reason it's not considering is because I separated the headings out separate. Okay, so it's something I've done manually. It's not by default.
Okay.
Okay. So yeah, moving on. So NumPy, again, as I said, mathematical operations is the mainstay of NumPy. So let's start looking at some of the arithmetic operations that NumPy offers us. Okay, so I've just listed a few here. There are many. So some of them are, you can raise the power of every single element. So this is where NumPy is very powerful. What you can do to all the elements in a single go. So you don't need a loop to run through each element like you would in a list, right? So if I use numpy.power, I can raise the power of every single element of that array to any value I want. The same way I can apply trigonometric functions to every element. Add, subtract, and multiply each element separate, right? So let's take a look at how that works. Just go down. Yeah. So you see here I have some variable called calorie underscore squares, right? So I'm using np dot square. So what does np dot square do? It raises the power of each element of this calories. So what was calories? It was basically this column, right? Except the heading, the rest of this column, all these numbers, it's going to raise each of them to the power 2. The same way protein underscore signs is going to take the sign value of each and every single number here, right? So calorie okay. So this was using a specific function for square. So you can have for square, you can have for cube. But what do you do for other powers? You use the general function np dot power. So when I use np dot power, I pass the calories, right? Calories holding all these values. I'm passing that array, and I'm saying raise it to the power 2. So you can see that this is power 2, this is power 2. So it should come out the same, right? Let's see how that works out. Yeah. Okay, so this is the calorie square. So the first thing is, you see the first value is 70 and it got squared. Second value is 120, it got squared, right? So similarly, every single element has gotten squared. The same way the protein, okay, so protein, the first value is 4, right? So you can see that if I go here, sine of 4 is minus 0.75. So minus 0.75. So you see that it's taken the sign of every single value, right? And as we discussed, np dot power with a power of 2 should give me the same as the square, right? So let's see if that works. Yes, it does. You can see that it's the exact same matrix in both cases. So np dot power is the general case, and np dot square is just a specific function for squaring alone. Okay, so the more powerful function is np dot power. And let's have a look at adding, subtracting, and multiplying. So okay, so if I do, so I'm doing calories plus protein, right? So I'm just adding every single value in calories to its corresponding value in protein. So 70 plus 4, 120 plus 3, 70 plus 4, 50 plus 4. That's how it should come out. And for that, I'm using the command np.add. Okay, so numpy dot add, and when you pass the two here, obviously for addition, it does not matter. The order does not matter. Protein comma calorie should give you the same as calories comma protein, right? Because addition is, it doesn't matter in which order you add. But when it comes to subtraction, it does matter. So here I've said calories comma protein. So it should do calories minus protein, right? Again, for multiplication, it doesn't matter. There is a division command as well. So there are multiple such commands. So this is just meant to show you that these are the many things you can do with NumPy. So the important thing is you get an understanding of exactly why NumPy is so powerful. Because I'm able to do this for every single element without having to iterate, right? So let's run this and see. So you see 70 plus 4, right? So 74 is the first one. Then I have 120 plus 3, 70 plus 4, 50 plus 4, right? So it just added the corresponding values in both the calories and the protein, right? Oh yeah, sorry, forgot to ask. Is the size of the notebook fine? Do I need to zoom? Can you
It
guys
is
see
fine,
everything?
Srinivasan. Yeah, it's fine.
Okay. Okay, so that was for addition, and now let's see subtraction. So as I said, the order was important. If I had done protein comma calories, it would have subtracted the other way, right? So I did calories comma protein, so it's interpreted as calories minus protein, right? So 70 minus 4, 66. 120 minus 3, 170. So it goes that way, right? And multiplication, you can see. So in multiplication, what I've done is I haven't done calories and protein, okay, which you could have obviously. So the reason I did calories comma calories is it's very easy to compare with our initial result. Calories times calories should give you the same as what we got here. So you can see that this array and this array are the same, right? So 4900, 14400, etc. Right? So multiply works too. Right. So that was some arithmetic operations that NumPy offers. So let's go into another aspect of NumPy that's actually very useful. It's about the shape and stacking of arrays. Okay. So what is the shape of a NumPy array? So it's the number of elements along each, axis. So what does an axis mean? Okay. Simply put, it's basically the rows comma columns, right? So you see, I have this array. It's a two-dimensional array. Why? Because you see that it's an array of arrays, right? So it's a two-dimensional array, and I have these elements. So what do I have? Basically, I have three of these internal elements, three rows in a way, and two columns, right? Because like so this 3 rows and 2 columns is what gives it a shape of 3, 2, right? So that's how you find the shape of an array. And using the shape, what we can do is we can do things called stacking. So stacking is basically you arrange arrays along various axes to form bigger, newer arrays, right? So I have these arrays, let's say some example 2 arrays. So what does it mean to say stacking along the vertical axis? It basically means that I take each and every single element and I stack them vertically. So what does an element here mean? So you see the element of A in a way is 2, 3 and 3, 4, right? So those elements, and here it's 1, 8 and 0, 4. So they got stacked vertically, right? So this is what vertical stacking is. So there's vertical stacking, then there's horizontal stacking, in which case you just stack horizontally, right? Then you have column stacking. So let's take a look at these, and it will become clearer. Head to this side now. Yeah. So that okay. So just to keep it clear, like the arrays here were kind of big. So I'm going to take an even smaller sect of this. So what I'm doing is I'm slicing, right? So I'm slicing the calories array. I'm taking the first, like, there is only one row in that array actually, if you remember. Uh, the calories array has, like, it's just one contiguous thing, right? It's a 1D array. So I'm slicing the first three elements, right? Similarly with protein. So let's just run that. And you can see here that I've sliced. So you see, I've sliced 70, 120, and 70. That's why it was 0, 3. What does 0 mean? I can slice along the same line, right? It's just 1D array, so it does not matter. And you slice the first three elements. The same way from protein, it should be 4, 3, 4. Right? So let's just see that it is. Yep, it's 4, 3, and 4. So I have these arrays. I'm calling them A and B. So yeah, it just helps to keep track of the variable names here. Just remember that A is the subset of this calorie and B is the protein subset, right? Now what I'm going to do is I'm calling the variable horizontal, and it's a horizontal stack of the arrays A and B. So what does horizontal stack mean? Okay, I've got this row here, this row here. So if I stack them horizontally, it will become one continuous array, right? 70, 120, 70, 4, 3, 4. right? And what does vertical stacking mean? That I have these two arrays and they'll be stacked one below the other, right? And what does column stacking mean? Column stacking basically means that, okay, what's the first column in this array? 70. What's the first column in this array? 4. So I stack, like I put 70 and 4 together as one element. Same way I put 120 and 3 together as one element. 70 and 4 together as one element again, right? So let's just see that, show you again. Right. So why did horizontal stacking do this? I took this array, right? This 70, 120, 70. I took 4, 3, and 4, and I put them side by side, and I managed to get this array. This is called horizontal stack. And what did vertical stacking do? You can see it picked up this array, it picked up this array, and put them together vertically. So the vertical putting together basically made it a two-dimensional, right? And column stacking, what did column stacking do? It picked up 70 and 4, made it one element. 123 made it one element. 74 again made it one element, and then put them all together in an array, right? So this is, once more, it's a 2D array, but you can see that the shape is actually different for each kind of stacking. So depending on the need, you can stack in various ways. So this was stacking. And another thing that is part of this, a continuation of this, is shape manipulation. So what does shape manipulation mean? That, okay, if I have this as shape 3, 2, can I make it some other shape depending on my usage? Yes, you can. So for this, there are three commonly used functions. One is called ravel, one is reshape, and one is resize. Okay, so what does ravel do? It basically unravels an array. In a way, it flattens it. So what does flattening mean? It just converts it to one dimension. I'll show you that on the notebook. And reshape and resize actually do the same thing, but they have a very important difference. So let's have a look at what exactly that is. Right. So what I'm going to use here, I'm going to use this vertical array. So what is vertical? It's this. You can see here that vertical is my vertical stack array basically, right? So I took this and I stacked it vertically and I got this. So this is what I'm calling vertical, and I'm going to use this as my, to show these functions, right? So I'm just going to keep it like this so you can actually see both. Yeah. So now I'm going to call vertical dot ravel, right? So ravel, so the thing is ravel, reshape, and resize are actually functions of an array. So you call array dot whatever function. So array dot ravel. And why doesn't ravel have any argument here? Because it's just unraveling it into a 1D array. What does it mean? Basically, it's going to pick each and every single number and put it together in a 1D array, right? So you can see here that this was the original array, and after using the ravel function, right, so that's here, you can see it became 1D array, 70, 120, 70, 434. So it's called flattening the array. Okay, it's basically scientific term is flattening this array. And now we use reshape. So what does reshape do? I'm saying you take this array, right? So how many elements, how many numbers does it have? 1, 2, 3, 4, 5, 6. So I have these 6 numbers, which are right now they're organized. And like, what is the shape now? There are 2 rows because there's one this array, one this array. So that's 2 cross 3, right? So right now we're at, we took this 2 cross 3 array, this thing, and I'm saying make it 3 cross 2. So why am I able to do this? Because 3 times 2 is 6 and 2 times 3 is 6. So basically, if you multiply columns by rows, you should get the same number of elements in both. Obviously, because we're not actually changing anything, right? So we're doing this vertical dot reshape 3, 2. So this is basically telling it that you take this array and you reshape it as a 3 by 2 array. 3 by 2 array as in each small inner array will have 2 elements and there will be 3 of those, right? So you can see that happened here. It took these elements and it combined them as 70, 120, 74, 34, right? So 70, 120, it picked up these 74, 34. So it goes in order and it puts them together. So you have 3 of these small inner arrays which have 2 elements each. So it's a 3 by 2 array, right? And the important thing here is this vertical array, which was the original array that I called, is remaining unchanged, right? Which is the biggest difference with the next command, that's resize. Resize takes this array and it's going to resize, like it's going to permanently change this array. So vertical dot resize 3 comma 2 is going to, in the end, it's going to get the same array. But where reshape was creating a new array, resize is going to change the original array. So when I print the same vertical, it's changed. It's no longer this. So after this, wherever you use vertical, it will no longer have this kind of distribution. It will have this. So that's why it's very important to, like I mentioned it here, an important difference is highlighted. So you need to be careful using these functions because reshape does not change it, while resize actually changes the original array, so you can actually use it. Any doubts? Any doubts? Okay, so I'll continue. Okay, so then we have three very simple functions. Numpy dot zeros that literally just creates a function, an array that creates an array of a specific size that the user wants and fills it with zeros. The same way, numpy dot full is basically the general case of this. It creates an array of the size that the user wants and fills it with whatever number the user wants. So you can see it's going to create a 3 by 3 array like here. And the second one is the number that it's going to fill, second argument. So it fills with all 55s. And the data type is int, so it doesn't go for 55 point. Like here it's 0 point. But by default, it chooses the float, right? And numpy dot identity basically creates an identity matrix of the size that the user wants. So let's just quickly run these and check it out. Right. So this is standalone. It does not have anything to do with the data set really. So you see numpy dot zeros 2 comma 3. So I wanted 2 by 3 matrix with all zeros. So you can see it's 2 by 3. Why is it 2 by 3? Because each of the inner arrays has 3 elements and there are 2 of those. So it's 2 by 3. The same way, the same 2 by 3, instead of 0.0, I want 99. So it stores 99 in all of them. And 3 by 3 identity matrix is what I've asked for here because I used np.identity 3. So like an identity matrix can only be a square matrix, right? So you only need one value actually. So when you say 3, it automatically interprets it as 3 by 3 matrix. And it gets this identity matrix 100 0 1 0 0 0 1. So where is this useful actually? The usefulness comes in the like all these functions are useful in different situations. Like numpy dot zeros is useful for initialization. If you just want to create an array and later you change the values, then you set it to 0 so that it doesn't affect normal arithmetic operations like addition and subtraction. The same way, np dot identity is important when you're doing matrix multiplication. Right there, a numpy dot zeros array will simply mess up the multiplication. But any matrix times identity is the matrix itself. So that's where the identity matrix is useful, right? So that's where you use np dot identity, and np dot full has fairly limited use in terms of initialization, but yeah, sometimes you do use it. And the last part is like we're just touching upon file operations here. NumPy is actually not known for file operations. So the issue is that I have written this code here, right? So file data, I am using this function and NumPy dot generate from a txt file, right? So this file that I'm passing is data.txt. It's some normal txt file. So what's a txt file? Basically a notepad file. When you save it, it comes with the extension .txt, right? And the delimiters. What is the delimiter? The delimiter is basically what is separating two different values that you should consider in that txt file. So if I have 3 comma 2 comma 4, then the delimiter is comma. So it takes 3, it takes 2, and it takes 4, right? But these will be a string. It may be a strings. So you want to convert it again to an integer data type, and then you print this. But that's not the point. The point is that here to use a CSV file is actually fairly difficult, and this is actually where Pandas comes in, right? So Pandas allows you to deal with CSV files. So Anirudh will be talking about Pandas next. So before we move on, any doubts in the last part or in general? Okay, so I just take it that no doubts. Okay, so yeah, that's it for an introduction to NumPy. And yeah, Anirudh, over to you.
So, hello guys, am I audible? Is my voice clear?
Yes, go ahead.
Okay, yeah. So I think I will get started. 1 second. Okay. Is my screen visible?
Yes.
Yeah, it
Okay.
is.
Okay, so hello guys. I'm Anirudh Kalyan from BTech Mechanical Engineering at IIT Madras. I'm also a coordinator at CVI. And today I will be taking your introduction to the Pandas library. So until now, would have gotten a basic idea about what Python is, and a bit of an introduction to Git, and then we moved on to NumPy. And NumPy is a very useful, and if you're actually interested in data science and you want to pursue it further, you'll notice that you'll be used everywhere. And the sister NumPy is almost always said extensively with Pandas. They're almost like together all the time. So I will be teaching a bit of an introduction towards Pandas, and so before we move on, like I also want to know I also want you guys to keep interacting. So like probably just tell me how you guys are feeling with probably some reactions. We'll see how well the interaction is right now. Any reaction apart from raising hands? Okay, you have a copy. That's very good to know. So yeah, Srinivasan and I we are using the same CSV. So here is the CSV that we are using. This is about 1 kilobyte in size. So that is about 88 rows 77 rows with 16 columns, as he said. And this is what we'll be working with today. So here is a look, and you can also, of course, it has been already added to the group, and I think I have shared it. If not, I will share my notebook as well right now. 1 second. I'll put it in the chat so that those who want to can access it as well. Yeah. So those who want to access the notebook can also do the same. And now we'll get started with Pandas. So, I mean, Pandas apparently this I got to know very recently, which is Pandas is it is actually a short form of panel data. So that kind of gives you an idea of what Pandas is, which is it is used for manipulation and analysis of data. That's basically what this library is about. And it's built on top of NumPy, and it is for Python, as we can see. So first, let's get started with importing. Here are some of the libraries I'll be using: Pandas, NumPy, and Copy. So here, if you run it, we can see that it runs. Now, I honestly want to keep this less about pandas and more about serials. So, as you know, we have a serial data set here, which, as you can see, I have the data set right here. Another good thing is to read these documentations, because you will be seeing that the person who has created, the author of this data set, has created a lot of abbreviations. So I think it's always good if you're using any data set to quickly go through the documentation to understand what we're working with. So yeah, here we have it. And this is how you define or understand and import a data set into Pandas, which is you define it. We usually put it as df, which is data frame, which is basically just a table. It's a fancy way of calling data frame, a table as a data frame. And we are using read underscore CSV. So this is a CSV file, which, as Srinivasan said, you can upload from here if you're following along. And so hence we have read underscore CSV. Pandas also allows you to read from Excel and TXT. But for today's demonstration, we will be sitting with and working with CSV. As this is, this is usually also what many of the data sets are available in. So I think CSV is a good place to start with. So if you go ahead and import this, yeah, we should have
Excuse
no
me
issues. Uh-huh.
for interruption. Can you please post that link which you have shared in the comments in the WhatsApp group?
Sure. 1 second.
Yeah, it has already been shared.
Yeah, I've already done it.
Okay. So I think we should have no issues. So yeah, anything, of course, please feel free to interrupt. An uninterrupted session will feel very dry, even if it's just me talking. So I think interruptions are good, as long as they are constructive. So anyways, proceeding, let's talk about serial. So our goal at the end of the session is to draw a few conclusions with serial, with respect to serial. So that's your Kellogg's, your American food meals, whatever was given in the data set. Our goal is to draw a few conclusions. So that is what we do with data science, isn't it? We have a bunch of randomized data and we align it, we organize it, and then we draw conclusions from it. And Pandas is a tool that will help us do just that. Hence, we'll be talking about serial and we'll be seeing how Pandas can help us go about our goals. So first, let's just look at what in all columns that this data set has, as in under what ways have we segregated this particular piece of data. So if you open it here, we have name, MFR, which if you go and check the acknowledgements and the content, it says it's manufacturer. And then we have type, calories, protein, fat, sodium, fiber, carbohydrates has been shortened to carbo, sugars, potassium, vitamins, shelf, which is shelf life, weight, cups, and rating. Cups here is the nutrition information. They'll usually be given a serving size. So how many cups, which is how many ounces is one serving, is what they mean by cups in this data set. Rating is apparently a rating from Consumer Reports. Even the person who has published this is not sure. So we're not going to talk much about rating in this session. Okay. So now let us first try and access the rows of a particular column. This is a very simple thing that we can do even using normal Python lists. But of course, they're already starting with a range instead of just individual elements. In Python, you'll mostly be familiar with discrete elements. And so here, if you notice, first thing is that, let me first execute it. So wait, I'll also show you the CSV on the side. 1 second. So I think the first 4 rows, I have put manufacturer, which will tell you the column. And I'm telling how many rows I'm expecting from this particular column. So we are saying 1 to 5. So if you say 1 to 5, it will remove 5. Just like how in range, we'll say for I in range 1 to n will be exclusive. Just like that, it will start at 1 and it will end at 4. So that's your manufacturer. So your QKKR comes here. It's a pretty simple function, really. So for the purpose of the first part of the session, which is going to be viewing. So Pandas is usually used for 2, manipulation and analysis. Analysis is basically representing the data that is easier to look at, right? So if you have noticed in Numpy, when Srinivasan was going around with and playing around with the arrays, they were always shown as what? Nested lists, right? That gets the job done, but it's not really very convenient to look at. Whereas if you look at the output of Pandas, you can see that it's actually done in a very nice table. All the spacing has been taken care of. And so that is one step easier in necessarily approaching and comprehending the data that is being thrown at you. So this already Pandas makes it easy for you in that. Just viewing the data is so much more easier than having a nested list. So anyway, but moving on to the next thing, which is in the initial, I had to refer to the documentations to see MFR and then Carbo and things like this, which I don't want right now. So for the sake of even more convenience, what I'm going to do right now is I'm going to rename MFR to manufacturers. So that is what I've done here. For that, we use df dot rename, and then we open. So now this df is, by the way, the object of the array. So this is the array that will be taken, the data frame. And then we are telling that you take this data frame, you rename. What should I rename? Then you're giving the columns which you want to rename. So you're taking you're taking MFR, which is the old, replace with the new. Potash, rename it to potassium. Carbo, rename it to carbohydrates. And we are also using in place equal to true, which is basically, it achieves the same thing as putting df is equal to this. Here, it is there to save memory in large scale applications where it will directly discard the old data frame and make way for the new one, which is basically saying it's as good as putting equal to this, and I can remove this. That is the job of in place. Is everything clear till now? And a reaction would do. All right, fine. So that is where we are right now. So what did we do until now? We took a data set, we are now we are just slightly renaming it for better presentations. That is what we're doing until now. And we're also going through how Pandas will help us in viewing the data in a more simplistic manner. Also, if you are paying closer attention, what is object? Can anybody tell me what object is here? We've seen only int, string, and everything until now. What is object? Anybody? Chat would do. All right. So object is basically Pandas representation of string. This is pretty. This will be useful in a later command that I'll be going through for you guys. So just remember that object is basically another name for string, which is used by Pandas. So anyways, now that we have renamed everything, I think I can show you what it will look like right now. So if you notice, MFR has become manufacturer, and then carbohydrates, carbo has become carbohydrates, and potash has become potassium. Okay. Now let's move on to the next thing, which I want to do for further convenience, which is manufacturer. If you notice, has one letters N, Q, K, K, R, C, 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 C. This is not very useful if someone who has no idea about these abbreviations approaches this data set. Here in this case, I have the source. What if I didn't have the source? Then I think it's not good to work with data sets which don't have credible sources, but in an extreme case, still it's always good to expand these abbreviations. So these are the ones that we have been given by the source. So what I'm doing is I'm going and changing this using this command. Now I like to go into a bit of depth in this command. See, because Python is an object, like it's a programming language that plays a lot with objects. So actually each one of these are stackable commands. So I think if we can understand what each stack means, it will actually give you a lot of power to use this library. So that is why I'd like to go a bit more into depth with this commands. So here we go. 1 second. So we have so I think I've gotten this command onto here to kind of tell you what exactly each command tells you. So it's not a bunch of letters. Everything has a meaning here. So again, as I said, df, that's your data frame, dot lock. You'll have one more dot ilock, which I'll get back to the minute, but dot lock is dot locate. So data frame, you go to the data frame and you locate this column, which is named type. So that is this one right here, type. And in that type, if let us say whatever you're located has the string s, h. So here this particular thing will give you a string. And if that is equal to h, you make that as hot. This is the syntax that Pandas uses. So this is your replacement string, this is a return string, and this is a Boolean expression. If this Boolean expression passes to true, then it will move on here and it will replace that into hot. So that is exactly what we have done for all the brands here. So C becomes cold, H becomes hot, and N becomes Nabisco, American Kellogg's, General Mills, Post, Quaker Oats. You have all of this. Finally, we print out the data frame, and this is much better to read. What do you say? Compared to a nested list, Pandas has helped us to change everything. And we didn't even have to run an iteration. This is just the 7 different brands that are there. So this amount of code is required for any sort of data analysis. So now we move on to the next thing, which is ilock. So if you notice, pay attention to the fact that we're using LO's lock, which is locate, which is based on locating based on labels. If you notice, I'm always referencing the table based on a label, manufacturer, and type. These are all labels. These are all strings. Whereas we usually reference elements using numbers. So for that we use ilock, integer location. So now here we notice again within Pandas allows you to either find a discrete element or a range of elements. So first I'll show you what happens if we execute ilock 1, 5. That will give you a discrete element. So 1, 5 is 0, 1. Hold up. That's a row. 0, 1. And then in this it's 0, 1, 2, 3, 4, 5. So that's your 5 right here. So that is your 1, 5. So you're accessing a discrete element. If I were to do 1:5, so 1, 7:5, you get all the rows. So this will give you a range of rows. Am I understood? So it is always that if you're putting 1:5, you'll just get all the rows. And if you're putting 1,5, you'll get row, column. That is how the syntax works for pandas. Anyways, the syntax really does, like, I feel at this point, like, the syntax doesn't matter. Rather, what pandas can do overall, I think, matters at this stage. So I think if you know that we can access a particular data set, an array, with both labels and numbers, it's a pretty powerful way to do it. So anyways, moving on. Now, another thing about data is it's usually pretty random. They are very organized, but at the same time, there's a bit of chaos. Usually, they are not sorted. They are sorted in various ways, but there are several ways you can sort a same data set. So in this case, what if I want to see all the cereals that are done only by Kellogg's? So that is what I've done here, which is I've taken the data frame. I'm trying to locate. What am I trying to locate? I'm going to the manufacturer column of data frame, and I'm saying, if you find Kellogg's in written in manufacturer, then give me that. So that's what we have here. Notice that it's always all Kellogg's. So that is, here. I'll come back to that. So that is what we are doing here, aren't we? We're taking data frame, and we are taking Kellogg's, and we are saying, if the manufacturer column has Kellogg's in it, then you give me all of those together. So that is what we have on this side of the command. Again, just understand that this is one particular function. The syntaxes, I'm sure, like, even if you try your best to go through them right now, it really, when you're trying to apply, you will correct yourself. So that shouldn't be a big deal. The key is understanding that we can do all of this using pandas. Now, what I'm doing right now is I'm taking the same thing and I'm giving it to a second data frame. So until now, I was only displaying this data frame. It is not saving it anywhere. Now I'm assigning this to a variable, df2. Now, when I take df2, there's another issue with this, and which I just said, which is that we can sort tables in various different ways, right? So in this case, I'm trying to sort it based on who the manufacturer is. In this case, I've chosen Kellogg's, but I can also sort based on what your fiber content is based of each of these Kellogg cereal. Notice how we are going deeper and deeper. We had extreme amounts of data. We had 80 cereals as given by Kaggle, 77 to be exact. And then in that, we are choosing Kellogg's. And in that, we are finding which is the most fibrous cereal Kellogg's can offer as per this data. So Pandas is helping us do this. So it's a tool that helps us get such very specific answers to specific questions. So for that, we use sort values. This is your new command for this block. Sort values, again, it's notice the syntax have a certain amount of similarity to them. You take the data frame. What do you want to do with the data frame? You want to sort the values. And with what basis you want to sort? Fiber. We are choosing fiber. And we are choosing ascending equal to false, which is basically descending order. If you don't put this, it will give you ascending order. By default, it's true, which is what I've written here. Here, we have taken sort values. Here, we don't use df. In some places, we do df of fiber. In this case, we don't use a data frame of fiber. And default is true. And all the fit are in descending order, which I can show you right now. All brand with extra fiber, understandably, has the most amount of fiber. Also has the highest rating, surprisingly. Anyways, so that is what we have, and Rice Krispies is understandably at the bottom. So that is kind of the thing of finding it in decreasing order. If you had to find this out of 77 different data, I think it would be a lot more difficult. So now this is what we have with respect to ascending and descending order in a particular data frame. Let's move on. Before we move on, do we have any doubts in this? I did cover a couple of concepts here. Raise your hand or ask in the chat. It will be so much more fun. So do we have no doubts? Just react with a clap or something if you have no doubts, so we can move on. Okay, fine. So next up, let us also find another interesting thing, which is we can use multiple booleans as well. So right now, I will show you this later, but
There is actually a doubt.
Okay, yeah. Anthony Roshan. Okay, yes, we can actually. That's what I was about to say. Okay, by sort, do you mean pulling out the values or in ascending descending? Because ascending descending, you cannot, like, if it is a bit of a you cannot sort in ascending descending. But if you mean, let us say I want Kellogg's and hot, then you can. The Pandas does allow you that. Is that your doubt? Is that what your doubt is, Anthony? Yeah, cool. That's what I'm saying. Yeah, 100%. That's what Pandas allows you to. So actually, right now itself, I can show you. I had it down here. Where is the end? I can do it right now in front of itself. That's fine. So the thing is a bit different. Syntax is or we have to modify a bit. So you have to put and you have to put df of let us say calories greater than 110. So all you need is Boolean expressions, right? So I will try and give you another one which is not just equal to equal to. Let's see. So notice calories is greater than 110 and manufacturer is Kellogg's. Now the good thing about Python is it's the Boolean expressions need not be binary. You can give as many, you can just keep putting and. Like I'll wait one second. That's what makes at least I think Python a very good place for all of this, which is it offers you this stackability of functions. So if I put carbohydrates greater than, let's put 15. Now we're down to 3. So we can keep on stacking this, which allows us, again, in this case, we have 77. But what if we're looking at 150,000 rows? Then like these kinds of stackable sorting will like save your memory and save your time a lot. So yeah, it's a very powerful library that we're talking about. It seems very simple, but it's honestly extremely powerful. Anyways, so as it again sorted it in descending order based on fiber, which 332. Because again that is what we have told it to do, and I think your doubt would have been cleared. Or is there anything you want me to elaborate further, Anthony? Okay, cool. So let's move on to all right. Yes, so once again, last time what did we do? We sorted out based on manufacturer. Now let's sort based on type, which is, if you notice in the initial data set, it's literally all just cold. Cold, everything's cold actually. There are only very little hot cereal. So if I do this, you notice that there are only 3. And so again, finding these obscure data types also you can do using this LOC function lock. So again, I'm showing the stackability which I just demonstrated earlier. You'll have to show protein content greater than 3 is achieved using this Boolean data type. So see, the idea is inside of this, you need something that returns a data type. I mean, a Boolean data type, right? So that is the idea. Protein greater than 3. If it's yes, then it will return true. If it's true, then it will take that row and put it out. So that is the kind of basic, very, very fundamental syntax of this function. And so now this is the next thing for when we are on to the final quarter of this demonstration. Now what I want to do is, of course, cereal being a morning snack, your sugar content should not be very high. I did a little Googling before the session, and for adult men, the total amount of sugar they're allowed per day is 36 grams. Okay, and so if a cup of sugar, which is about a cup of cereal, has around like 8 grams of sugar, it's already pretty unhealthy. That's just your morning cereal. So like if you were to filter out cereals which are unhealthy on that front, right? So we would again need to, so that's what I'm trying to do. I'm trying to single out the cereal which are unhealthy for consumption on a regular basis. So that is what I'm doing. So sugar, if it's greater than 8 grams per serving, then you give me that. Right. Again, you take the data frame, you locate. What do I locate? I locate sugars. And if the sugar is greater than 8, you give me this. And when you give it to me, you sort them based on sugar and you sort them in descending order. So that is the base. That's what this line of text tells you. You take the data frame, locate the sugar, whichever is greater than 8, give that to me. When you give it to me, sort them in descending order based on the value of sugar. So now I'm printing it out. Boom. So here we have sugar. 15, 15, 14. Golden Crisp, Apple Jacks, Cocoa Puffs. These have like, this is literally a third of your sugar intake if you put 1 cup, which is like 1 cup is almost what you would eat in the morning. So yeah, Fruit Loops, 11 grams of sugar, just all incredible high amounts of sugar. Sorry, 12 grams of sugar. So yeah, point has been proven, which is, yeah, these are all like extremely unhealthy cereal and they have an incredibly high amount of sugar and we have filtered them out from the plethora of data that we have been given. Now let's move on to the next level of sorting. In marketing applications, the name of a cereal plays a big role in increasing the appeal of the cereal. If I told you Raisin Bran, you will immediately recognize that, but you will probably not recognize the brand which it was from, which is Post. But so the name contains a very powerful implication. So now how will I find a name using this? So here I have chosen 2. I've chosen Crunch and I've chosen Bran. These are the 2 things which I remember to be common when I eat cereal. So I've chosen these 2, and this is what you do: df locate df name s.str contains crunch. So until now, this is all we are beaten to death at this point. And then here we have, this is your new command that I'm trying to tell you guys. So here we go. Now, remember I told you in the beginning of the session, Pandas stores this as an object data type. Although it's a string, it's an object data type, which is not exactly a string. But this contains function needs a string data type. So you add a middleman, which is .str. So you take the data frame, you locate all the names, and then you typecast them into a string, and then you find which ones will have a substring. And in this case, I've chosen the substring to be crunch. So if I come here, if I were to print this, you'll find Cap'n Crunch, Cinnamon Toast Crunch, and Honey and Nut Crunch. And funnily enough, there are 4 brands which are using the word crunch. Again, it's a bit of a marketing implication there, but yeah. And if we were to do this one, which I've also added .reset index, which is the updation over this one. The updation that I've added here is that I've added one .reset index, which if you notice is pretty self-explanatory. I have only 4 here, but look at the index. It's 10, 12, 38, and 48. That's just not good to work with. So if I change the name to Bran, now there are 12 cereals which have the word Bran in them. So clearly a pretty powerful name when it comes to naming cereals. And you can see literally all the brands use it. Kellogg's, Post, General Mills, Nabisco, everyone uses this particular name. Once again, analysis, right? We have this data, we sort the data and we analyze them based on what we want to achieve. So in this case, I have a marketing thought process, like I have a marketing notion in which I want to see how powerful is the brand, and the more number of cereals that have them, more possibly they are more successful. That is the thought process. And you can see, now that I've reset the index, you can see it starts from 0, 1, 2, 3 and all the way to 12. Excuse me. So yeah, now we'll move on to deep copy. This is not necessarily in Pandas or Numpy, but this is something that I found to be very useful when you're working with data sets, which is you have to not just, in some cases, if you directly copy arrays, we would have studied, some of us have studied that an array is basically just, the data type of the array is basically a pointer that points to the first element. So if there is a chance that the variable could be pointing to the same array. So even if you put it as df4, And if you put df4 equal to df, there is a chance that you could be sabotaging your df itself, which is your original array, and you don't want to mess with that if you're experimenting with df4. So that is where deep copy comes in. It makes a completely separate copy, which is completely independent from df, and which means your original data frame will not be affected from your experiments in data frame number 4. So once again, it will run without any issues. Now, we have a final bit which we are going to do is, until now, what we have been doing is we've been trying to find out how the data looks like. We've been trying to analyze the data, not manipulate the data. There's a fundamental difference, right? Until now, I've been telling you in different ways how you can see how the data is. But now I want to also touch upon how you can change the data for your own good, manipulate the data such that it's easier to work with. So in this case, if you notice, 0.67, 0.5, these are cups. So if you're trying to make a neutral health analysis, this cups should all be 1 in reality. Once again, due to like several lobbying reasons, these people get away with actually putting 0.33 cups and putting calories. So what you will do, I mean, not you, what a general public would do who is not aware of this, they'll see 120 calories here and they'll see 70 here and they'll see this is more healthy and they'll buy this, less calories. But actually this is more healthy because you're having thrice the amount for 120. Whereas if you were to triple this, you'll get 210. So this is not really a representative number, calories. So how do I change that? I use an iterative method here. I'm trying to show you another way in which we can do this, which is we can access the same data using iteration. So for index comma rows in df4 iter rows. Again, this is, you don't necessarily need to remember everything in, like as it is, but this command basically goes through each row's iteration by iteration, so that you'll have a bit more granular access to them rather than putting if you don't like indexing them in using LOC. So now inside that I'm running a nested loop. So what am I doing? I'm going inside this row and I'm changing the columns which will be affected by tripling or doubling the size of the cup. So what if proteins will double, everything will double, right? If you have double the amount of calories will double, protein will double, fat will double, sodium will double. So that's what I'm doing here. I'm taking this and I'm dividing by the number of cups there are and I'm changing the cup to 1. So if I do that, which if I run the command, it should run perfectly fine. And again, what I'm doing is I'm sorting them based on calories. So before if I sorted them based on calories, this will be higher and this will be lower, right? But in reality, that is not the case. This actually is more calorific than this cereal. 100% natural brand is more calorific. 100% brand is more calorific. So again, I'm using the same sort values function that we saw before, and I'm printing out your new array, which is this. Notice that
Sorry to disturb. It's already 4:50. Maybe can we?
Yeah, I'll wrap up within 5 minutes. Yeah, we're almost at the end. Just thank you very much. So again, your calories, you see it has shot up to 212, and this is staying at 120. And when it's doing this, the division ends up being float division, which we can also change into integer if you want. So Srinivasan talked about as type. So if you can use as type to change this into integer if you're not comfortable viewing at 6 decimals for every particular value that we're looking at. So finally, I'll just finish up by looking at which is the most unhealthiest cereal in terms of calories. You can do this in terms of sugar, but anyways, the idea will be the same. I'm doing this by separating our big data frame into 7 sub data frames for each brand. So I'm having Kellogg's, General Mills, American, Nabisco, Post, Quaker Oats, and Ralston Purina. So I'm creating 7 sub data frames. So if I run this, my 7 sub data frames have been created. We have gone through the syntax of this command and what it exactly does. And inside this, what I'm doing is I'm putting all the highest value calories. So see, this dfg.calories.max is actually pretty simple. We'll break this up very quickly. I think I should have it here. No, okay, so I don't have the explanation here. So DFG of calories.max basically returns you one number, which is the maximum amount of calories in DFG, which is General Mills' complete lineup in this data set. And then I'm going back into the column and seeing which row corresponds to this maximum value of calories. So that I'm assigning to DFG. So DFG has become the value of one row rather than an entire array. And I'm doing that for all 7 brands. Right. And then I'm doing the same thing all the time, and I'll get the 7 highest calorific cereals from everybody, from every brand. So that is what we're having here. Once again, it's what we've been doing since before. You'll be seeing this dot log a lot because we are trying to extract data. So we'll be locating the data a lot. And we are seeing the max function, which has been introduced here. And we are taking this value and we're comparing with the entire row's value. And hence we have this, which is, as you can see, Post actually has the highest calorific cereal at 440 calories. You can make your inferences from here. And now we're finally doing what we're doing is we are checking the average amount of sugar and calories every manufacturer adds to their cereal. So right now I've mainly done calories, the third row's calories, if you can see 0, 1, 2, 3. So I have done based on calories. You can done based on sugar as well. So what I'm doing, I'm integer locating semicolon comma 3. So this semicolon basically tells you that choose all the rows. So as I said, rows and columns. The left side of the comma will be the rows and the right side of the comma is the column. So I'm saying choose the third column and choose every row in the third column. That is what this means. And I'm saying dot mean, which will give you the average. Again, we are stacking up commands. As you see, some of these you have seen before, some of these you haven't, but these are stackable, which means you can play around with them. And when we do this, once again, you'll be able to see that, okay, here I'll have to go back and run the data set such that we have the arrays instead of the rows. That is improper variable naming. And here you can see, you can sort this if you want, but here for the sake of time, I'll just show that Post has the most calorific average, followed by Kellogg's, then Nabisco closely by Quaker, and then American and Ralston Purina. So yeah, so as you can see that the mean is the main focus in this particular application. And then finally, I'll finish up with saying you have imported into CSV and you're played around with this data. And now you have a more condensed piece of data. And now we use 2_CSV to now export this into a data file. So I'm calling this modified.csv. And I'm saying, when you give me the CSV, also give me the new index. So if I run this, if I go to this, you will see modified.csv just appeared. So if I do this, you should see the new CSV with all the highest calorific index right over here. So that has been the basic view of Pandas. I will share you the collab notebook as well as other materials that I have followed to come up with this session. If you have any other doubts, of course, please feel free to ask in the chat right now. Thank you, guys.
Okay, so I guess that's the end of it. So as Anirudh said, all the notebooks and all other PPTs will be shared on the. You can also look at the GitHub repository to find the recording after once the session's recording is processed, we'll upload it there. We'll upload it like after every session, so you can just keep keep following that so that you're also apprised of whatever the content that we are using and the recordings. All right. So according to the schedule, next session will be on Friday. It will be again from 2 p.m. to 4:30. So yeah. So I guess thanks a lot for attending, and yeah, one round of applause for the coordinators. Okay, I guess we can back. Yeah, I think you can start packing now. Will be good.